Okay, so multiple regression is the basic foundation to understand multivariate regression. And we must be knowing that multivariate regression is one of the simplest machine learning algorithm, and it comes under the class of supervised learning algorithm. So that's the reason we are studying multiple regression to understand the concept behind it, but then we'll not be covering multivariate regression in this particular video. Now, to understand multiple regression, if you remember the examples that I took last time, it was a simple linear regression example, and we subsequently have shown the plotting in R. So in a linear, simple linear regression, there is just a one dependent variable and one independent variable. So the dependent variables we call either their outcome or response variable or the responses. The independent variable are basically the predictor variables or the explanatory variables. So those explains the responses of the dependent variables. So we'll be using Ewells notation here. You can get in any standard statistics manual or book. Let us say we have three random variables, x1, x2, and x3, with their means as x1 bar, x2 bar, and x3 bar. So in our example of multiple regression, we will take three variables, two as dependent, two as independent, and one as the dependent. So we'll always keep x1. We will keep x1 here as the dependent variable, right? We'll keep this a dependent variable, and x2 and x3 as the independent variable. And based on that, we will formulate the equations. The reason why I want to discuss is we need to understand the mathematical concepts behind multiple regression a little bit thoroughly before we move to part B, where I'll show you a plotting of the multiple regression in R. So let me share you the example or the formula. Just, excuse me. Yeah. As per the Ewells notation, is widely accepted in the statistical world. The relationship multiple regression is x1 is equal to a plus b. Do not get overwhelmed by these syntaxes. I will explain you one by one. Okay, so x1 is equal to a plus b 1, 2.3. It signifies this is known as the partial regression coefficient. This is known as the partial regression coefficient of x1 on x2, keeping three aspects. So basically what it says is it is a partial regression coefficient of x1 on the variable x2, that is the dependent variable x1 on independent variable x2, keeping x3 fixed. Similarly, for this one is again the same thing, with just swapping between 3 and 2. So B13.2, it means the partial regression coefficient of x1 on 3, keeping 2 as fixed. So what it means is A is the standard intercept of what we saw in the simple linear regression example. What it means is this is intercept plus the regression between 1 and 2 keeping 3 fixed, and regression of 1 on 3 keeping 2 fixed. So that is how it is related. Now, so far so good. Now, if you understood till here, so you can also observe by yourself that x1 is dependent on x2 and x3, and there is a coefficient in between. So there is a multiplication of coefficient with x2 and x3, and this is what we call it partial regression coefficient, and we have to relate it with the correlation coefficient that we studied last time. So the whole idea of this equation is to understand how more than one variable is related to one variable is related to more than one variable. It means if we have more than one predictors or the independent variables and one response or the outcome uh, variable here in this case, or the dependent variable x1, such kind of relationship or such kind of regression model are called multiple regression. So before I go to the next question, let me tell you that in multivariate regression, you have a multiple set of responses or multiple responses or the outcome or the dependent variables. And that is what we will discuss in our subsequent videos. But here we will focus only on the multiple regression. So the coefficient B 1, 2.3 means partial regression coefficient of the variable x1 on 2, keeping 3 fixed. And similarly, B13.2, it means partial regression coefficient of 1 on 3, keeping 2 fixed. Now we will try to derive a relationship between these regression coefficients with the correlation coefficient. That's the whole idea of the regression, multiple regression models mathematically. Oh, well, x1 is equal to a plus b12.3, x2 plus b13.2, x3, and if we subtract, before we do the subtraction, we can divide this by n if we have n observations. So this is the mean x1 bar. This becomes equivalent, right? 3 x2 bar plus b13.2 x3 bar. I will quickly go through the equation so that the video doesn't become too long. I will skip some of the complex derivations which you can do offline, not difficult. Now we subtract x1 minus the x1's mean, so this will become 12.3, and this is the way I pronounce it. 12.3 means regression coefficient of 1 on 2, keeping 3 fixed. So let us keep it simple in pronunciation. Thus, same thing here, except the coefficients are different and the variables are different. So this is very, very simple, right? Now this if we call small x1, this we call as small x2, and this we call small x3. So small x1, small x2, and small x3 signifies the difference or the distance from the mean, right? So if we take this as a small x1, the equation translates to x1 is equal to equation 1 on 2, getting b1 to bx2 plus b132 x3. You'll be wondering why I'm showing all these things, so just have patience. You'll understand why it is important to understand what we are doing. Now this x1 basically is the estimate of x1, right? X1 is the, as I said, is the distance from the mean or the difference from the mean, which is an observed, x1 is an observed value, but this x1 is an estimate of x observed value. So this is also referred to as x1, 2, 3. This x1 is also referred to as x1, 2, 3. This regression of coefficient of 1 on 2 and 3 together. In case of a multiple regression, we call it this way. So here we have two variables. We can have more than two variables as well. And if this is, if x1 is an observed value or an observation, and x1.23 is estimated value of x1, then obviously there is an error. Both are not same. So the error will be what? The error will be x1 minus x1.23. Simple, right? This is represented as E1.23 and also known as error of estimate, or it is also known as a residual. Depending on the authors of the statistics books and related to the residual or the error of estimate. Right? So we have error residual or error of estimate of regression of 1 on 2, 3 is equal to x1 minus observed value of x1 minus the estimated value of x1. Okay. So an estimated value of x1 we have found out is what? What is estimated value of x1 here? The same thing. This particular, right? That is the regression coefficient, one coefficient into x2, another coefficient into x3. So we just write it down here, the same stuff. These are the repetitions actually. Put my pen in the right place. Sorry, I'm very sorry. B12 dot x2 minus B13 dot x3, and all these are small x, that is distance from the mean. Right. This we can also say this residual error also equal to x1 minus x1.23, which we have seen, could implies the estimated value of x1 is equal to same things. We are just interchanging the positions. The observed value minus the observations. Right. This is for three variables. So if you consider n number of variables x1, x2 up till xn, so this equation can be written in this format. So x1, the estimated value, will be equal to the regression coefficient of 1 on 2, keeping all other variables fixed from 3 to n, into x2 multiplied by x2, plus the regression coefficient of 1 on 3, keeping all other variables fixed, multiplied by x3, plus, and so on. So, and this is the error or the residual or the error of estimate will be x1 minus all of this. x1 minus all of this. This is an estimated one. So this is the theory of the errors, how to find out the equation and the residual. The important thing of what I wanted to tell you is as per least squares method, we will be finding the minimum. So this is what we use it. Now, for since x1, x2, and x3 are the difference from the mean, or we can say the distance from the mean or the difference from the mean. So obviously the summation of x1 and summation of x2 and summation of x3 will be 0, right? Now, based on the least square method, this should be the minimum. The square of the error or the residual should be minimum, right? And if we take this as some value, say v, then we can say that partial derivative of v on the regression coefficient of 1 on 2 keeping 3 fixed should be equal to 0, and this should also be with respect to 1 on 3 keeping the other fixed 2 fixed. This is from the concept of maximum and minimum values, right? So interesting thing that I wanted to tell you is ultimately if you solve these equations, substituting the value of residual, what we found out here, residual values, this the equation, if you substitute here, ultimately we're not going into the details of calculations here in the interest of time. So ultimately the result that I'm interested in is that regression coefficients, one of the regression coefficient will be equal to the standard deviation of x1 divided by standard deviation of x2, and this is multiplied by the correlation coefficient of 1 on 2 minus correlation coefficient of 1 on 3 and multiplied by correlation coefficient of 2 on 3, and this whole is divided by 1 minus correlation coefficient square of 2 and 3. So this is the relation between the regression coefficient of 1 on 2 keeping 3 fixed and the correlation coefficient. So this is an important outcome. Similarly, we have another coefficient, and we will subsequently plot this in R, and we'll see how to find it out so easily. But you should understand the underlying mathematics. That's the whole idea of showing it. R1 to R2 3 divided by 1 minus R square to 3. So I'll show you why we need these values. So what are these two things? These are basically the relation between regression coefficients and correlation coefficients, right? So this is very important. Now we'll move to one more phase. So variance of residual. Again, I do not get overwhelmed with this formula. I just wanted to show you this because you may encounter this many times in your statistical modeling when you plot in our regression models. So this is how the formula looks like, the variance of residual. That is 1 by n summation of the error 1, 1, 2, 3 minus the mean of that residual whole square. And the variance of residual, when we convert it in the form of correlation coefficient between the variables, so it looks like the second formula. Basically, the variance of residual in terms of the sigma 1 is the standard deviation for the variable 1, which in our case is a dependent variable, and or the outcome variable or the response variable, whichever way or whatever we want to call it. And how is it related with the correlation coefficients? So fine, we are not deriving it, just wanted to show you. So far so good. Now coming to the another concept called multiple correlation. What exactly it means? If you see the formula here, correlation, multiple correlation coefficient, which is normally denoted in capital R. Capital R multiple correlation of 1 on 2, 3 means if you see the equation, it says the degree of association between an observed value of dependent variable and its estimate obtained by multiple regression. So basically, it is a degree of association between x1 and the estimated value of x1 based on the regression model. So that is how it is defined as the multiple correlation. So first of all, we have initially we had 3 variables, x1, x2, x3. Then we found out the multiple regression for the estimate of x1 based on x2 and x3. Now we are trying to find out the correlation between x1 and its estimate, right? That is called multiple correlation. So these concepts are very important when you do a further plotting and further modeling in multivariate regression as part of machine learning. So this is what I wanted to show you all about. Now, if I take a small example before I close this part. So far we have taken x1, x2 and x3. Let us take one example, a very basic example. Let's say it's 2, 6, 10. We're not going to solve it. I just want to show you why we read so much of the formulas and what is the use of those formulas. This is just one trivial example, right? It's 2, 4, 4. This is 6, 5, 6. This is 8, 9, 10, and 10, 11, 12. If I have to find out the multiple regression from these 3 observations where x1 is the dependent variable of x2 and x3. So what do I need to find out? I need to find out the final equation will be what we discussed is small x1 is equal to coefficient of regression and the other coefficient of regression multiplied by this will be the final formula, right? So we need to find out this, we need to find out this. We have a formula that we we derived in the first instance. See, we have the formula here. This is why I told you these formulas. This is the one. So these 2 formulas, we use this formula to first we'll find out the correlation coefficients between each of these variables, and we put it in the we find the standard deviation, and then we put in the formula to find out the regression equation. Right? Now, just remember one thing here. For these kind of observations, how do we find x1? X1 is, I told you, the difference from the mean. So you first find out the mean. First find out the mean, which is equal to summation of x1 by n. In the first case, the mean will be 6.5, right? So x1 minus 6.5 will be our x1. So whatever result we get, finally we will substitute that in x1 minus 5. Let us say x1 mean is 6.5 here, x2 mean is 7.5, and x3 mean is 8. So finally you substitute the value once you get x1, x2 and x3 using the equations that I showed you, right? To solve these kind of problems mathematically, you need to find out, as I said, regression coefficients and the correlation coefficients. And so what all you need to find out? You need to find out this value. You need to find out this value. You need to find out the correlation coefficients. You need to find out the sigma. So sigma 1, sigma 2, sigma 3. Formula for sigma 1 square is equal to 1 by n summation of x1 square, the small x1 square, right? And the big X minus the mean is equal to small x. So big X1 minus 1 is equal to small x1. So we know the value of this one, the mean. So you can find out from the distribution these values, and ultimately you can plot the equation where we have derived the very first beginning of this video. X1 is equal to estimated value is equal to regression coefficient of 1 and 2 multiplied by x2, regression coefficient of 1 on 3, keeping 2 constant, multiplied by x3, and finally substitute the value of x1, x2, and x3, and you will get a final answer, something like x1 minus 6.5. This is actually small x1 is equal to b12.3, and this is the small x2 map to the big x2 is the mean of big x2, and similarly you find out the third one, map it with the bigger value of this, and you will get one equation, and this is your final multiple regression model. This is how you solve it mathematically. Okay. Now the same equation I will show you how you can do it in R, but I will not plot it today because I'll leave it for another day. We'll take a real good example and we'll try to develop a regression model in part B. The same example, we'll just see what else we can do today. So I have three variables x1, x2, and x3, the same values I said are here. This now I'm getting a matrix. This 3. Show you the matrix if you want to see the matrix. Is same. So this is the matrix x1, x2, and x3. Now I'm converting it into a data frame because I want to fit it into a multiple regression model. This one, and then x1 tilde x2 plus x3. Unlike in the previous video, we had one independent variable. Here we have two independent variables. So we are doing the multiple regression here. Run it, and we find out the coefficient. This I call is at the model called fit, and we find the coefficient of the fit. If you see the result here, this is what I wanted to show you. You see the results here. This is the intercept that we were talking about. This is the A value. This is the second value that we were getting, the coefficient of regression of 1 on 2, keeping 3 fixed, and this coefficient of regression of 1 on 3, keeping 2 fixed. This is B12.3, B13.2, right? So now you can also find it out using these First is the intercept, and is the regression. First coefficient, second coefficient. Now, one thing I wanted to tell you, and which you are aware, we are not going to plot it now. Okay, we will plot it in our next with a better example and bigger example. But I want to show you one more interesting thing here. So if I take some other variable before I go into the other variable, let me first find the rank of this matrix which we were doing so far. So the rank is 3, and we have 3 variables, and the rank is 3. So this is okay. That's the reason you're not getting some strange results. Let me show you what I mean by that. Now I have changed these variables. I've taken these variables, and if I run the same thing here in the matrix, and let us run this whole program itself, I get a coefficient as NA. So the reason being, if I try to find out the rank of the second matrix, I get the rank as 2. So that means one of the variable is linear combination of the other variable. So in this case, the rank is coming less. This is a linear combination concept. So I'm sure you are aware of it. So your rank must not be less than the number of variables. Otherwise, you will not be able to find out the regression coefficient. So I'm not going to plot the graph further. In the next video, we will take a bigger example and better example, and where we will try to predict the value of x1 based on 2 other independent variables, and we will plot a real multiple regression model, and we will see how can we predict the variable x1 based on the various values of x2 and x3. So leave it for the next video. I wanted to explain the basics, the mathematics behind it, because unless you understand the difference between multiple regression and multiple correlation, it will be difficult to understand and interpret multivariate regression, which is the basics of, or in a way, a very simple machine learning algorithm that we use. So these are very important concepts. So thanks for watching, and wait for my part B, and we will plot it in our